Welcome everyone. In this video, I am going to talk about the very important Lagrange method of multipliers. In case if you are new to the channel, you should subscribe it because here you get good quality video content. Now the point is that what is Lagrange method of multiplier and why should we use it? So in my previous video, we have studied about how to find the extremum. By extremum, I mean the maximum or minimum value of a function. But Lagrange's method of multiplier helps us to find the extremum of a function under certain given constraint. Constraint means restriction. So there may be certain restrictions which are imposed, and based on those restrictions we need to maximize or minimize any given function. So let us quickly go through the basic things and then we will do the problem solving. So in many practical problem we need to find maximum or minimum value of a function, right? The function is dependent on n variable. When the variables are not independent but are connected by one or more constraint which may appear in this form, like so here I am writing k constraint because I is varying from 1 to k. So the Lagrange method of multiplier helps us to find the extremum. So what is the method? So suppose we want to find the extremum of this function, right? F of x1, x2, xn under the conditions. The conditions are given by this. So how many conditions in total are there? In total there are k conditions because I can take the value from 1 to k. So there is phi1 x1 to xn equal to 0 and phi2 x1 to xn is equal to 0. So there are k conditions. So what is the first thing we do? We first construct the auxiliary function, and you need to understand this step very carefully because sometimes they ask questions based on this. So we are writing an auxiliary function f, right? And this auxiliary function f is f of x1, x2, xn. Basically here I could have written in place of f, I could have written simply like also like f of x1, x2, xn, and along with that it is going to have different multipliers, that is lambda 1, lambda 2 up to lambda k. So this function f actually is this function. And how it is defined? We first take the original function which is dependent on n variable, and then we take the summation of lambda I times all the given constraints. So the constraints are k in number. So here there will be k terms, lambda 1 times phi 1 x1 to xn plus lambda 2 times phi 2 x1 to xn and so on. Here the lambda i's are undetermined parameter and are known as Lagrange multiplier. We determine the stationary point by solving equation 1, equation 2 and the following condition. Means we differentiate the auxiliary function with respect to x1, equate it to 0. We differentiate this function with respect to x2, equate to 0. Differentiate this function with respect to xn and equate to 0. So we get certain condition, and by solving 1, 2 and all these equations together, what we get is the stationary point. Now Lagrange's method of multiplier has a limitation that it only gives you the stationary point. It does not help you in identifying the exact nature of those points, that whether these are the points of minimum or maximum, or whether the function will attain minimum value or maximum value at that point. So for that we need the further investigation. Now the question is to understand it through the problem solving, because it might not have made much sense to you. So we are going to solve many problems and that will help you to understand this thing. So I'm going to take the first problem. So what is the process of solving this? So we have a function which is given f of xyz. So we have to find the minimum value of x square plus y square plus z square. So let me call this function f of xyz, and which is equal to x square plus y square plus z square. And we have a constraint. The constraint is xyz is equal to a cube, which we can also write as xyz minus a cube is equal to 0. So we have just one constraint. See, we are writing the constraint like phi I of x1, x2, xn is equal to 0. So that is why I brought this a cube in the left and I wrote the constraint like this. This is my function. This is my constraint. So what is the next thing? Next thing is to write the auxiliary function. So we write auxiliary function. So how do you write the auxiliary function? The important thing to note here is that to write the auxiliary function, we have to use k number of Lagrange multiplier. But here how many constraints are there? We have just one constraint. So we just have to use one Lagrange multiplier. Means I am going to write a new function, that is the auxiliary function, and I am representing it by capital F x y z comma lambda, because we have just one constraint. So I will just take one multiplier, and this is equal to x square plus y square plus z square and plus lambda times x y z minus a cube. Okay, now what is the next thing we have to do? This function actually has three variables, x, y and z. So I am going to differentiate this function with respect to x first. So if I differentiate this function with respect to x, the first bracket will give me 2x, and the second bracket will give me lambda times here we have lambda is a constant, xyz, lambda actually is a parameter. So if I take lambda out, xyz will give me what? Xyz will give me lambda yz, and we have to equate that to 0. So we get the equation that is 2x is equal to minus lambda yz. Similarly, we need to find the partial derivative of the auxiliary function with respect to y. So I will get 2y plus lambda xz. I hope you got it. Derivative of x square will be 0, z square will be 0. So I just have to write 2y, and here lambda and xyz. So lambda is a constant taken out. Derivative of xyz will give me xz, and that I have to equate to 0. So from this I will get 2y is equal to minus lambda xz. And then we have to calculate del f by del z. So that is equal to 2z plus lambda xy, that is equal to 0. So this will give me 2z is equal to minus lambda xy. So we have different equations. Now we have to solve all this along with the help of the first and two to get the stationary point. Okay. So to solve this, I can move to the next page, but one operation I want to do here, that and it will be easier for us to write it here, because it will take more time if I move to the next page. So what I do, if you look at this equation that I have got, I multiply both sides by x. So from here I will get 2x square is equal to minus lambda xyz. If I multiply this second equation here by y, I will get 2y square is equal to minus lambda xyz. And if I multiply the third equation by z here, I will get 2z square is equal to minus lambda xyz. And you are smart enough to understand that I have done it because it was kind of symmetrical, and now all the three things, all the three equations have the same right hand side. So from this we can conclude what? That since right hand sides are equal, so I can conclude that 2x square is equal to 2y square is equal to 2z square. So basically this is actually nothing but x square is equal to y square is equal to z square. So we have got a relation between x, y and z. But basically I want to get the stationary point, right? We want to get the point at which the function may attain its extremum value. So to solve it further, we are going to use the constraint that we have. The constraint that we have is x, y, z is equal to a cube. So if you look at this equation, and if you look at this equation, what do you get? That you get that if I use this both of them, we obtain. Can you guess what are the solutions that we are going to obtain? We obtain the points as, let me write points as. So we have to take x, y and z all equal. Means we have to not equal, but we have to take it in such a way that x square plus x square is equal to y square is equal to z square, and xyz should also be equal to a cube. So one thing is very obvious, that I can take a, because if I take a and all the three as a, then this condition will be satisfied and this condition will also be satisfied. Another possibility is that I can take a and y I can take minus a, and z also I can take minus a. So in this case also x square is equal to y square is equal to z square, and xyz will be a into minus a will also be a cube. We can take something like minus a a and minus a. So that is also a possibility. So basically what we are doing, out of the three variables, we are taking two of them as negative and one of them as positive, so that xyz is equal to a cube. And as you can guess, that one of the points will be minus a, and a. So we have got these 4 points. These are the 4 critical points or stationary points. So in question, if they ask find the critical points or stationary points, the answer should be given up to this. But in the statement, they are asking that find the minimum value of it. So if I take all these points, we can write that at each of these points, the above point, each of these points, the value of the given function, the value of f of x, y, z is equal to, what is f of x, y, z? The function that we have is x square plus y square plus z square. So if I take any of these points, the value will be equal to 3a square, right? But the question is, we have to show that it is the minimum value of it. So Lagrange's multiplier method does not tell you that whether this value is minimum or maximum. What it tells you, that these are the stationary point. So if these are the stationary point, the function may have a minimum or the function may have a maximum at this point, but I am not sure whether this function, whose value is coming to be 3a square at each of these points, whether this is a minimum value or maximum value. So to ascertain that, or to guarantee that, we are going to use a result which we have studied in our previous classes. So see, this is the limitation of the Lagrange's multiplier method. What is the limitation? That they just give you the critical point. So up to this, we have used the Lagrange's multiplier method. Now next we are going to use the further investigation. So what further investigation we are going to do? So we know from our previous classes, what we know, that the arithmetic mean for any set of number is greater than or equal to the geometric mean. So here I am going to take the arithmetic mean of the numbers x square, y square and z square. So if I take x square plus y square plus z square by 3, this is the arithmetic mean. And how do you calculate the geometric mean? You multiply x square into y square into z square, and you take this power is equal to 1 by 3, right? But it is given that xyz is equal to a cube. So it means what? That it will be a cube, I explain it here, a cube square to the power 1 by 3. So basically a to the power 6 to the power 1 by 3. So this will be equal to a square. So from this we conclude what? We conclude that x square plus y square plus z square is greater than or equal to 3a square. So what does what is the meaning of this, or what should we conclude from this? That we conclude that the value of x square plus y square plus z square is greater than or equal to 3 square, means what is the minimum value? So the minimum value of x square plus y square plus z square is equal to 3a square. So the value that I have got at all these critical points actually was the minimum value. I hope you understood this. Now moving ahead, let us do this problem, and this is even better problem, so it will help you to clear your doubts absolutely. So find the extreme value of this function such that x square plus y square is equal to 5 and x plus z is equal to 1. So how many constraints are there? Actually there are two constraints. So what is the first step? We write the auxiliary function. Auxiliary function, I'm using the symbol capital F, because a small f I have used here to write the original function. So auxiliary function will be given by f of x, y, z, and how many constraints are there? Two constraints. So I am going to take two Lagrange's multiplier, that is lambda 1 comma lambda 2. And how do I write the auxiliary function? So I write the original function, that is 2x plus 3y plus z, and plus lambda 1 times the first constraint. So the first constraint is x square plus y square minus 5, and then plus lambda 2 times the second constraint, that is x plus z minus 1. Now let me call this equation number 1. So next thing is that we need to find the auxiliary equations. So the auxiliary function I need to differentiate it with x, y and z respectively. So for extremum, you can write, to get the extremum value, I find del f by del x. So if I find del f by del x, it will give me 2, the first bracket 2, the second bracket will give me plus 2 lambda 1 x, and third one will give me lambda 2, and that I have to equate to 0. So this will give me the equation like, means it is already in the nice form, so I don't have to write anything else. So this is the first equation that I have got. Okay, and I'm calling this first, so let me call this second. Now if I differentiate this with respect to y, so what will I get? Del f by del y. So I will get 3 plus this will give me 2 lambda 1 y, and there is no y term, so that will be just it. So I will write that is equal to 0. So this is the equation number 3, and then we differentiate it with respect to z. So del f by del z will be equal to, first one will give me 1, second one will not give me anything, right, because there is no z. Third one will give me lambda 2, so I write lambda 2 is equal to 0. So this is equation number 4. Now I have to solve this, all these equations along with the given constraint x square plus y square is equal to 5 and x plus z is equal to 1 to get the critical point. So how to solve them? And I will suggest you to pause the video at this moment and try to solve these three equations, equation number 2, 3 and 4, with the help of these two constraints to get the critical points. Okay, so let us do that. So I hope you have tried. Now I am going to move further to help you in case if you have not been able to. So to solve this, what I am going to do, I am going to write this, that from equation 4, from 4, what we get? From 4 we get lambda 2 is equal to minus 1. And I put lambda 2 is equal to minus 1 in equation 2. So from 2 I will get 2 plus 2 lambda 1 x, and lambda 2 is equal to minus 1, so that is equal to 0. So this will give me 1 plus 2 lambda 1 x is equal to 0. So this will give me x is equal to minus 1 by 2 lambda 1. Okay, so this is the value of x that I have got. Now if I look at the second equation, I am going to use this space because moving ahead will create some confusion. So if you use the equation number 3, so I am using a different thing. So from 3, actually you have to write it under. So from 3 I will get y is equal to minus 3 by 2 lambda 1. So I am getting x is equal to minus 1 by 2 lambda 1 and y is equal to minus 3 by 2 lambda 1. So I am writing it here, x is equal to minus 1 by 2 lambda 1 and y is equal to minus 3 by 2 lambda 1. Okay. Now the best part is that we have got x and y both in terms of lambda 1, but there is a constraint that is given to us, that is x square plus y square is equal to 5. So it is given that x square plus y square is equal to 5. So using this I can write in place of x, if I write minus 1 by 2 lambda 1, I will write minus 1 by 2 lambda 1 square, and in place of y I will write minus 3 by 2 lambda 1 square, that is equal to 5. So this will give me what? 1 by 4 lambda 1 square and 9 by 4 lambda square, so that is 10 by 4 lambda 1 square is equal to 5. So this will give me 4 lambda 1 square, or let me write it directly, it will give me lambda 1 square is equal to 10 by 20. I hope you got it. Why? Because you see here it will be like 10 is equal to 20 lambda 20 lambda 1 square, so I will get 10 by 20, means that is equal to 1 by 2. So if lambda 1 square is 1 by 2, lambda 1 will be equal to plus minus 1 by under root 2. So we have got two values of lambda. Now if I take lambda 1 is equal to 1 by under root 2, what is the x? So x is minus 1 by 2 lambda 1, so 1 by under root 2, so that will give me minus 1 by under root 2. What will be y? Y will be minus 3, it is given, by 2 lambda 1, so that will be like minus 3 by 2 into 1 by under root 2, so that will give you minus 3 by under root 2. So we have got x and y, but next question is how to get z. So to get z we have another equation, that is x plus z is equal to 1. So it is given that x plus z is equal to 1. So from this I can get z is equal to 1 minus x, that is equal to 1 plus 1 by under root 2. So the point that I have got is 1 plus 1 by under root 2. No, sorry, x, this is the value of z. So the point, the first critical point that I have got, x is equal to minus 1 by under root 2, y is equal to minus 3 by under root 2, and z is equal to 1 plus 1 by under root 2. To get the second critical point, if I take lambda 1 is equal to minus 1 by under root 2, so why I am making so many mistakes today. So lambda 1 is equal to minus 1 by under root 2. So can I write x directly? It will be minus, so minus minus will become plus. I will get 1 by under root 2. What will be y? Y will be 3 by under root 2. And what will be z in this case? Z in this case will be 1 minus x, that will be 1 minus 1 by under root 2. So the point that I got here is 1 by under root 2, 3 by under root 2, and 1 comma 1 minus 1 by under root 2. So we have got two critical points, sorry. Now up to this, Lagrange's multiplier method will help. Now after this, the means Lagrange's multiplier method role is over, because this method just gives us the process, or it helps us to find the critical point. So we have got two critical point, and whether it is a point of minimum or maximum, because in the question they have asked that find the extreme value. So how to decide that? So what I am going to do, the function that is given is f of xyz, that is it is given, let me write it for our convenience here. It is given that f of xyz is equal to 2x plus 3y and plus z. So what I do, I first take this point. So at point minus 1 by under root 2, minus 3 by under root 2, and 1 plus 1 by under root 2, I calculate the function value. So function value at this point, minus 1 by under root 2, minus 3 by under root 2, and 1 plus 1 by under root 2 will be how much? This will be equal to 2 times this, so minus 2 by under root 2, plus 3 times, so minus 9 by under root 2, and plus z, so plus 1 plus 1 by under root 2. So it will be 1 here, and minus 9 and minus 2, minus 11 plus 1, so minus 10, so minus 10 by under root 2. So I get 1 minus 5, 10 can be written as 5 into 2, so that will be 1 minus 5 into under root 2. So what I have to do next is, we don't have a space, so I have to move to the next. So we have calculated the function value at one of the point. Next we have to calculate the function value at the second point, that is what is the function value at the second point, means f of 1 by under root 2, 3 by under root 2, and what is the z here? Z here is 1 minus 1 by under root 2. So 1 minus 1 by under root 2. So the function value is 2x, so it will be 2 by under root 2 plus 3y, so 3 into 3, that is 9 by under root 2, and plus z, so that will give me plus 1 minus 1 by under root 2. So this will give me what? This will give me 3 plus 2, 9, and minus 1. So 1 plus 11 minus 1, so 10 under root 2. So I got the function value, that is 1 plus 5 into under root 2. So we have calculated the function value at both the points, and it is very clear that what is the minimum value. So this is the smaller one, so this is the minimum value of the function, and this is the maximum value of the function. So I just write that minimum value is equal to 1 minus 5 into under root 2 at the point, this point that we have calculated. And what is the maximum value? So maximum value is equal to 1 plus 5 into under root 2. So did you notice one thing, that if you are getting more than one critical point, you can calculate the function value at all the points separately, and the one which is maximum is known as the maximum value, and the one which is minimum is known as the minimum value. Now let us quickly take two more problems. So the first one is that find the smallest and largest value of this f of the function is of two variable x and y, so x plus 2y on the circle. So basically what we have to do, we have to take the function that is f of x comma y, it is given to be x plus 2y, and there is a constraint that we can't take any random point, we have to take the points only on the circle. So basically we have a constraint like x square plus y square minus 1 is equal to 0. So the process remains same, we have just one constraint, so we write the auxiliary function, that is f of x comma y comma lambda, right? So that is the original function, that is x plus 2y and plus lambda times the constraint, that is x square plus y square minus 1. So step number 1, we differentiate the function f partially with respect to the first variable x. So I will get 1 from here, and from the second I will get 2 lambda x, and that I have to put is equal to 0. And we have to differentiate this again with respect to y. So I will get how much? I will get sorry, 2 plus 2 lambda y is equal to 0. So basically what is the value that we have got? We have got from this, we have got the value of x is equal to minus 1 by 2 lambda, and from this the value of y that I will get is minus 2 by 2 lambda. I hope from the previous problem you have understood that this is also an approach of solving the equation, that we can solve x and y in terms of lambda, and then we can substitute in the given constraint to get the value of lambda, and once we get lambda we can get x and y. I hope it is making sense to you. So let us proceed further. So we have got x and y. So it is given what is given, that x square plus y square is equal to 1. So this will help me to write minus 1 by 2 lambda whole square, that is 1 by 4 lambda square, plus 4 by this can also be written as minus 1 by lambda, but by the way I have to write 4 by 4 lambda square, that is equal to 1. So I have got 5 is equal to 4 lambda square. So this gives me lambda square is equal to 5 by 4. So lambda is equal to plus minus under root 5 by 2. So we have got two values of lambda. So first, if I take lambda is equal to plus under root 5 by 2, what is the x I will get? X I will get minus 1 by 2 times lambda. So 2 and into under root 5 by 2. So I will get minus 1 by under root 5. And what will be y? So y will be minus 2 by 2 times under root 5 by 2. So this 2 cancel, I will get minus 2 by under root 5. So the first point that I have got is minus 1 by under root 5 and minus 2 by under root 5. Now similarly we take the second point, that is minus so if I take lambda is equal to minus under root 5 by 2, then I hope you can clearly see that if I change the sign it will become 1 by under root 5 and 2 by under root 5. So the point that I will get is 1 by under root 5 and 2 by under root 5. So we have got two critical point. The first one is minus 1 by under root 5 and minus 2 by under root 5, and second one is this. So which one is the smallest and which one is the largest value? So I calculate the function value at minus 1 by under root 5 and minus 2 by under root 5. So that will give me x plus 2y. So x is equal to minus 1 by under root 5 and minus 2 into 2, so 4 by under root 5. So it is equal to minus 5 by under root 5. So that is equal to minus under root 5. And if I calculate the function value at 1 by under root 5 and 2 by under root 5, so I get 1 by under root 5 and plus 4 by under root 5. So that is equal to 5 by under root 5. So that is equal to root 5. So the smallest value is minus under root 5 and the largest value is plus under root 5. So this is how you can calculate the function value. The minimum is minus under root 5 and the maximum is so you can write it, this is the minimum value and this is the maximum value. So I hope by now the things are clear. So let us quickly solve this problem, and you can see these are the simple problem, can be asked as multiple choice question also. So let us take the next one. Find the smallest and largest value of xy. So the given function here is f of x comma y is equal to xy, and the constraint is x plus 2y is equal to 2, and x would be greater than 0 and y should be greater than or equal to 0. So if you look at this graph here, it is not needed, but for your convenience I am drawing. Suppose I say this is x-axis and this is y-axis, right? So x plus 2y is equal to 2 means that x-intercept is 2, y-intercept is 1. So we are getting a line, right? And we have to find the maximum or minimum value of x into y on this line. It is given that x would be greater than or equal to 0. So we have this point, the boundary point is 2 comma 0, and here this point we have actually is 0 comma 1. I hope you are clear about this. This line can be written as x by 2 plus y by 1 is equal to 1 if I divide 2 here in this side. So intercept on x-axis is 2, intercept on y-axis is 1. So using the Lagrange multiplier method, first we write f of x comma y, and there is one constant lambda, so that is equal to xy plus lambda times x plus 2y minus 2. What is the next step? Find the partial derivative with respect to x. So I will get y plus 2 y plus lambda, sorry, not 2, because here we have let me change it here. So it is like y plus, if I differentiate it partially, I will get y plus lambda is equal to 0, and if I differentiate it partially with respect to y, I will get x plus 2 lambda is equal to 0. So from this I get y is equal to minus lambda, from this I get x is equal to minus 2 lambda. So now we have x plus 2y is equal to 2, means x plus 2y is equal to 2. So it means what? It means that first we have to take the value of x, that is minus 2 lambda, and then minus 2 lambda, that is equal to 2. So we get minus 4 lambda is equal to 2. So lambda is equal to minus 1 by minus 2 by 4, that is equal to minus 1 by 2. So if lambda is equal to minus 1 by 2, what is x? X is equal to minus 2 lambda, so that is equal to minus 2 into minus 1 by 2, so that is equal to 1, and y is equal to minus lambda, so it will be 1 by 2. So we have got a point 1 comma 1 by 2. So this is one of the critical point on this line. So what is the function value at 1 comma 1 by 2? So function value at 1 comma 1 by 2 is 1 into 1 by 2, that is equal to 1 by 2. Now one thing that you need to note, that if we are talking about maximum or minimum or smallest or largest value of xy on this line segment, you have got a point here that is on the line, that is 1 comma 1 by 2, right? This point, if you look here, it will be like somewhere this point actually coordinate is 1 comma 1 by 2. But there are 2 points at which we have to check the function value, because these two are the boundary points. If you have understood the concept of absolute maxima or minima, you might have realized that we can check the function value at the boundary point. So I calculate the function value at 0 comma 1. So at 0 comma 1 it will be 0 into 1, that is equal to 0, and we need to also calculate the function value at 2 comma 0, so that is 2 into 0, so that is also equal to 0. So did you notice one thing? They were asking what is the smallest value. So a smallest value is 0. So the smallest value is equal to 0. And what is the largest value? So largest value is equal to 1 by 2. Okay. So this is how we calculate the smallest and largest value. The largest value is occurring at the point 1 comma 1 by 2, and the smallest values are occurring at 2 points, that is 0 comma 1 and 2 comma 0. Sorry, moving ahead, let us quickly solve this problem, that find the extreme value of xyz. They are not asking us to find the maximum or minimum, so it will be easier for us, and it is given that when x plus y plus z is equal to 1. So again I take the function, that is f of x yz is equal to xyz, and the constraint is that x plus y plus z is equal to 1. So first step is to write the auxiliary function, that is x plus y plus z, sorry, f of x comma y comma z, and then Lagrange multiplier lambda. So that will give me x y z and plus lambda times the constraint, that is x plus y plus z minus 1. Now we differentiate f partially with respect to x, so I will get yz, and plus lambda, we have to put that is equal to 0. So this will give me lambda is equal to minus yz. Then we have to differentiate f partially with respect to y, that is equal to xz plus lambda is equal to 0, and this will give me lambda is equal to minus xz, and I have to differentiate it partially with respect to z, that is equal to xy plus lambda is equal to 0, and this will give me lambda is equal to minus xy. So to solve it, it is very much obvious, I hope to everyone, that I can multiply by x in this side, so I will get lambda x is equal to minus x, y and z. If I multiply it by y, I will get lambda y is equal to minus x, y, z. And if I multiply it by z, I will get lambda z is equal to minus x, y, z. So since right hand side is equal in all cases, means from these three we conclude what we conclude. Can you conclude that lambda x is equal to lambda y is equal to lambda z, which implies that x is equal to y is equal to z. Now x is equal to y is equal to z, but x plus y plus z is equal to 1. So x plus y plus z is equal to 1, and it is given that x is equal to y is equal to z. So what is the point I will get? I will get the point as 1 by 3 comma 1 by 3 comma 1 by 3. What you can do, I mean, you can basically put in place of y you can put x, in place of z you can put x. So 3x is equal to 1, so x is equal to 1 by 3. So 1 by 3, 1 by 3, 1 by 3. So this is the stationary point. Now at a stationary point 1 by 3 comma 1 by 3 comma 1 by 3, the function value is 1 by 3 into 1 by 3 into 1 by 3, that is 1 by 27. So this is the extreme value. They are not asking whether it is maximum or minimum, so I am just concluding that this is the extreme value, that is 1 by 27. Actually in the problem you might be thinking, sir, what is this a greater than 0? So basically the question actually was, I had a small kind of misprint here. So if you take x plus y plus z is equal to a, then in that case what will happen, if you want to take this question, a separate question, then in that case at this you will get x is equal to y is equal to z is equal to a by 3. So in that case the function value at the point a by 3 comma a by 3 comma a by 3 will be equal to a cube by 27. So that is what this a is. Since we have solved this problem, if you ignore this a greater than 0, then the question answer is 1 by 27. Okay, so I hope you have got this point. So this is all in this video. We have solved 5 problems related to Lagrange's multiplier method, and I hope the things are clear. So this is the last video in this series. In the next video I will be talking about the multiple integral, and I will start the new unit. In case if you liked, you enjoyed the video, share with all your friends, and do subscribe the channel if you have already not subscribed. Thanks for watching. Have a great day.